All right, let's dive in. Today, we're going to pull back the curtain on one of the real workhorses of the internet, the F5 Big IP system. We're going to see exactly how it manages the insane flow of traffic that keeps our favorite websites running.
I mean, have you ever really thought about it? A huge product launch, a big news story breaks. Millions of people all try to hit the same website at the exact same moment. How does it not just, fall over?
Well, it's definitely not luck. It's a super organized, incredibly intelligent system. And today, we're going to get to know these traffic cops of the internet and see how they keep everything moving.
So, first things first, we've got to start at the main entrance. You can think of it like a giant post office. Every single request from a user has to arrive at this one single mailing address first. In the F5 world, this is the virtual server.
Now, a virtual server isn't a physical box you can point to. It's a logical thing, an object that lives inside the big IP. It's basically the public face, the official front door for your application, living at a specific IP address and port. When you go to a website, you're not talking to a web server directly. You're talking to its virtual server.
But a virtual server is so much more than a simple door. It's a really smart bouncer. It's handling all the heavy lifting, like SSL security, but maybe its most important job is figuring out which actual server in the back is ready and able to handle your request. It's the brain of the whole operation, right there at the front line.
And the secret to how it does all this comes down to one core idea: full proxy. This is huge. It means the big IP doesn't just pass your request along. It actually terminates your connection and starts a brand new, separate one to the backend server. It sits right in the middle of two conversations, which gives it complete control to inspect, change, and route traffic however it needs to. That's the key to its power.
Okay, so your request made it past the front door, the virtual server. Where's it headed next? Well, it's going into the distribution center, the mailroom. And F5 calls this a pool.
So a pool is just what it sounds like. A group of back-end servers all set up to do the same job. Instead of the virtual server sending all the traffic to just one machine, it sends it to this whole team of servers. This simple idea is pretty much the foundation for how websites can handle massive amounts of traffic.
And why do this? It's all about sharing the work. By spreading all those incoming requests across a whole group of servers, you make sure that no single one gets buried and slows down. This is the heart of load balancing and high availability. It keeps things fast and reliable for everyone.
All right, now we're going to peel back another layer and get to the real foundation of all this. We've talked about the virtual address and the mailroom, but what about the actual workers? This is where we meet nodes and pool members.
A node is the most basic piece of the puzzle. It's just a simple object that represents a real physical server on your network. All it really is an IP address. In our analogy, this is the actual person, the worker in the post office. It's the machine that's going to do the work.
A pool member, though, is way more specific. This is a critical difference. It's not just the server, it's a particular service that's running on that server. So it's identified by the IP address and a specific port number. So if the node is the worker, the pool member is the specific job they're doing, like sorting packages at station 80.
Getting this distinction is absolutely key to understanding how F5 works. A node is the machine. A pool member is the service on the machine. You can have tons of different services, or pool members, all running on one single node. This lets the big IP send traffic with incredible precision, not just to a server, but to the exact application that needs to handle it.
And for the network pros out there, this is where you get some really fine-grained control. You can take a server out of rotation gracefully for maintenance, letting current users finish up what they're doing. Or, if something's really on fire, you can just yank it offline immediately. This kind of control is crucial for managing a live system without causing a scene.
All right, we've met all the players: the virtual server, the pool members, and the nodes. Now, let's put it all together and actually follow a single request from your browser all the way to the finish line.
So you click, that request flies across the internet, and bam, it hits the public virtual server. The virtual server does its thing, applies its rules, and then sends your request on to the right pool. The pool then uses its load balancing logic to pick the best, healthiest pool member at that exact moment.
And finally, your request lands at that specific service running on that physical node. It's a clean, logical, and incredibly fast chain of events.
Now that's all great when everything's working perfectly. But let's be honest, things break. Servers fail. What happens then? This is where the real magic of this whole system comes into play, all thanks to automated health checks.
It all starts at the very bottom, with the physical server. The big IP is constantly sending out little heartbeats or health checks to the services running on the nodes. Let's say a check fails. The web service on a server isn't responding. The monitor immediately marks that specific service as down.
Since that service is the pool member, the system instantly flags that pool member as down, too. No questions asked. It's no longer a valid place to send any traffic.
And this status change starts to trickle up the chain. The pool is only as healthy as its members. So when it sees that one of its members is down, it takes note. And if all the members of a pool go down, well, the entire pool gets marked as offline.
And here's where it all comes together beautifully. The virtual server, our smart front door, sees that the pool it was about to send traffic to is now offline. So it just stops. It immediately stops sending any new traffic in that direction, automatically redirecting it somewhere else if possible.
So what's the end result of all this? The system heals itself. It detects a problem at the lowest level, and the information flows up the chain so that traffic is only ever sent to servers and services that are actually healthy and ready to work. For the user, it's a seamless, always-on experience. They never even know a problem happened.
It's really an incredible symphony of logic, all happening in milliseconds behind the scenes. And it kind of makes you wonder, doesn't it? What other complex, totally automated systems are out there, just quietly making our digital lives possible every single day? Thanks for joining us on The Explain.